Okay, welcome back everyone. Today we are going to take a look at dividing with exponents. So yesterday you took a look at the power rule and the product rule. So you looked at what happens when you're multiplying with the same base or raising something to a power. Today we're going to look at what if you have the same bases and you're dividing them. So the first thing we're going to take a look at here is we're going to do a little exploration. So we're going to take a look at x to the fifth. So what does x to the fifth truly mean? X to the fifth means x times x times x 5 times. Exponents are a way to kind of express repeated multiplication in easier terms. So what x to the fifth really means is x times x times x times x times x. And x squared just means x times x. When we simplify this problem here, when we're dividing the same two numbers, think about if you were dividing 2 divided by 2. Essentially, they cancel out because 2 divided by 2 is 1. It's the same thing with x's. X divided by x is just 1, and 1 times anything is just whatever you're multiplying it by. And then same thing, x divided by x cancels out. So what do we have left? We have 3 x's, and x times x times x is the same thing as x to the third. So now let's take a look at another one and then see if we can kind of draw some conclusions from those problems. We have 5 to the 8th power, which is a simpler way of writing 5 times 5 8 times. 6, 7, 8. And then 5 to the 5th power is 5 times 5, 5 times. And just like the last problem, we're going to cancel out 5 divided by 5. And it looks like we're left with 3 5s in the numerator. 5 times 5 times 5. We can simplify as 5 to the 3rd power. Okay, so now taking a look at both A and B, what do we notice? Is there a faster way? Because say, for example, I had x to the 120th power divided by x to the 90th. I don't want to write out x 120 times. So there has to be a faster way. And the faster way is you can subtract the exponents when you have the same base. So our base in A is x. So if we do 5 minus 2, we get 3. And we can write x to the third. Same thing in B, our base is 5. If we do 8 minus 5, we get 3. So our simplified answer is 5 to the third. So we're going to use that property to help us simplify these exponent problems without expanding them each time. Okay, so this is called the quotient of powers property. And what it states is if we have the same base, what we can do with our exponents is we can subtract them. M and P are just any numbers here. When dividing two powers with the same base, we subtract the exponents. Also, you're always going to reduce the coefficients by dividing or simplifying the fractions first. So you'll see that in some of these example problems right here. Okay, so simplifying each expression. So our first one here, I don't want to write x out 8 times and x to the third out 3 times. What I'm going to do, since these bases are the same, I'm just going to subtract my exponents. 8 minus 3 is 5, so my answer is x to the 5th. In B here, it's pretty much the same thing, except this time we have coefficients. We have an 8 and a 16. So what we need to do is we don't subtract 8 minus 16. With the coefficients, you actually apply whatever operation you're doing. We're doing division. 8 divided by 16 is not 2. 8 divided by 16, we need to reduce that fraction. And to reduce it, they're both divisible by 8. 8 divided by 8 is 1. 16 divided by 8 is 2. So that reduces to 1/2 right there. And now we can subtract our exponents here. If we do 5 minus 3, since they have the same base, we get x squared. So there's two different ways you can write this. You can write it as 1/2 x squared like that, or you could put 1x squared and leave that in the numerator over 2, or just x squared over 2. So whichever way you prefer. So now taking a look at C, we again have coefficients. So what we're going to do is we're going to divide those first. Negative 48 divided by 3 would be negative 16. And then we look at our exponents that have the same bases. We have x's here, and we have y's here. So if we subtract our x's, 9 minus 6 is 3. And when we subtract our y's, 4 minus 3 is 1. You don't have to put y to the first because that's assumed. But if you want to put the 1, you can. But if you just have the y, that also means y to the first. And that's all we can do there. So the quotient of powers property is pretty easy. What I want you guys to do is pause this video and see if you can try A, B, and C. Okay, welcome back. So I'm going to do A, B, and C just so you can check your answers here. 10 minus 2 would be 8. So your first answer is a to the 8th. Your second answer, you had to simplify 4 divided by 16 first, which is 1/4. And when you look at your A's, you have 4 on the top and 1 on the bottom. 4 minus 1 is 3, so you have a to the 3rd. And B divided by B would just cancel out. So you can have it written as 1a to the 3rd over 4. You could have 1/4 a to the 3rd, or you could have a to the 3rd over 4. All of those answers are correct. And then your last one here, you're going to simplify 21 divided by 14. They're both divisible by 7. 21 divided by 7 would be 3. 14 divided by 7 is 2. Your next part here, you have 3 different variables. You have A, you have B, and you have C. So you're going to subtract each of those. 4 minus 1, you have 3 A's, 4 B's, and 3 C's. So you can write it like this, or you can write it as 3 halves, or 1.5, but I like keeping it as a fraction. So it's up to you, whichever way you'd rather write that there. Okay, so now moving on to our next topic here, we're going to look at what if we have a quotient being raised to a power outside the parentheses. So if we had anything in here, let's pretend I had a 2. If I had 2 being raised to the 4th power, what that really means is 2 times 2 times 2 times 2. So 2 times 2, 4 times. So what this means here is this means x over y times x over y times x over y times x over y. And we know when we're multiplying fractions, you multiply straight across. So if I multiply all of the numerators here, x times x times x times x, you learned in your last lesson, when you're multiplying the same bases, you add the exponents. So that becomes x to the 4th. And then same thing, these all have an invisible 1. If you add them up, we have y to the 4th. So the question becomes here is, how do I do that without writing it all out every time? And the quicker way is you apply the power rule to each the numerator and denominator. And the power rule is something you've already learned, so this isn't that bad right here. So if we do that with this problem down here, A would be raised to the p power, and B would be raised to the p power. So anytime you have a fraction all in parentheses being raised to a power, make sure you raise both the numerator and the denominator. A lot of times people forget to do the denominator also. Okay, and also, again, always simplify your coefficients when you can. So we're going to take a look at these examples below. So just like in the example here, I'm going to apply this 6 power to the numerator and denominator. Remember, in power rule, you're multiplying. So we have 1 times 6, which would be 6, and then we have 1 times 6, so we'd have y to the 6th. We can't simplify it any further because x and y are not the same base. In our next problem here, we're again simplifying our numerator and denominator separately here, and they're both being raised to the 4th power. So I'm going to rewrite this one so it's a little easier to see. I have 2x squared being raised to the 4th power, and I also have y to the 3rd being raised to the 4th power. And these are just basic power rule problems that you've seen before. So what you do here is you don't do 2 times 4. There's an invisible 1 here, so it's actually 1 times 4. So what you end up with is 2 to the 4th power, which means 2 times 2 times 2 times 2, which is 16. And then you multiply your 2 times 4 here, which is 8. And then in your next problem here, you have 3 times 4, which would be 12. And that's all we can do there because we don't have any coefficients to simplify. X and y aren't the same base, so there's nothing we can do. Okay, so moving on to C here. Again, I'm going to rewrite it just to make it a little bit easier here. We have to apply this 2 to both the numerator and the denominator. So I have 3ab to the 3rd all being squared. And I also have 7c to the 4th all being squared. So now when I simplify that, the numerator, 2 times 1 is 2, so we have 3 squared, which is 9. There's an invisible 1 as the exponent with a. 1 times 2 is 2. And 3 times 2 is 6. And in the bottom here, we have 7 squared, which would be 49. And we have c to the 8th power. 9 and 49 cannot be reduced. The only common factor they have is 1. And we don't have any of the same bases, so that's it there. And then my last problem up top here, D, I'm going to again make sure I raise the 3 to both the numerator and denominator separately. So I'm going to do 2x to the 4th, y to the 3rd, all raised to the 3rd power, over 5x squared y to the 3rd power. I'll actually do that up here. Okay, so now we have 2 to the 3rd power, which is 8, 4 times 3, which is 12, and 3 times 3, which is 9. On the bottom, remember it's not 5 times 3, it's the same thing. It's 5 times 5 times 5. It's 5 to the 3rd power. You actually raise the coefficients to the powers. 5 to the 3rd power is 125, and then we multiply. 2 times 3 is 6, and 1 times 3 is 3. But this is the first problem here where we actually can simplify something after we do this. So the first thing we look at is, can we simplify 8 divided by 25? So are there any common factors between 8 and 25? Well, 2 does not go into 125 evenly. 4 does not go into 125 evenly. And neither does 8. So we can't do anything with that. But what we can do is simplify our exponents here that have the same bases. So these both have x and these both have y's. So 12 minus 6 would be 6. And 9 minus 3 would also be 6. And we can only do that because they have the same bases. Okay, so the last part of this video, I just want you guys to try the last 3 problems. So pause this video, and then when you're done, unpause the video or play the video and check your answers. Okay, so the answer here for A, the first thing you had to do was divide 12 and 18. The common factor they have is 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. And then what we do is we have the same bases, so we're going to subtract 6 minus 4, which is 2. So that is one possible answer, or you could have had 2x squared over 3. Either way, it's correct. Okay, our next one here, we have to make sure we're applying the power to both the numerator and the denominator. So we have 3x to the 5th being raised to the 3rd, and we also have 2y to the 6th being raised to the 3rd. So we have 3 to the 3rd power is 27, 5 times 3 is 15. 2 to the 8th in the denominator, or 2 to the 3rd, sorry, is 8. And then we have y to the 18th. And then we think, can we simplify 27 divided by 8? No. Our bases are not the same with x and y, so that's really all we can do. So there's your answer. And then our last problem here, again, we need to make sure we raise the 2 to both the numerator and denominator. Okay, so in the numerator we have 8 squared, which is 64. And then multiply. 4 times 2 is 8. And then 6 times 2 is 12, so b to the 12th. And then our denominator, 9 squared is 81, c to the 4th, d to the 10th. We definitely can't simplify any of our variables because we have different variables, none of the same base. But we think, can we simplify 64 divided by 81? So if you have a calculator here, you can definitely use it to see if when you do 64 divided by 81, do you get a reduced fraction? Or if you don't know, what you can do is see, do they have any common factors? And actually, they don't. So this would be simplified here, and that is your answer. Okay, so hopefully this video helps, and I'll see you guys in the next